Hi guys, it's been a while. I didn't record anything, but this is a fast video to show the progress, something worth to see. And I wanted just to show you the setup first because it's changed a lot during the days. And let me show you. This is the setup, and basically we have the high voltage at the bottom. This is the high voltage, and then we have the two coils inside, which is the HC and the output coil, the OC. That's what I referred to in the video, the HC and the OC. And we have the also the parallel capacitor. So basically, it's the HV coil, which I have two MOSFET to switch between. Let me show you. This is what I'm talking about. I'm sorry, this is got so big. It's my first design for the PCB. So it got so big, and it's based on Evo design. I changed a couple of things, but I discussed that with him, and it seemed to be okay. And but this for sure is too big to be a PC board. But I just made it that big because I didn't know how, so I'm learning. Anyway, I'm using this little PCB board to just for the snubbers. That's all. This is not used. So basically, I'll go back to the diagram. So basically, the HV have the two MOSFETs, and I'm talking about these two MOSFETs. That's what I'm referring to. And the HC, it depends. I have two of them. I'm using one of them. It depends on some conditions. I'm gonna show you later. And that's what I'm talking about here. These are the MOSFETs in here. I don't know if you see, yeah. So this is only the drivers, and these are the MOSFETs I'm talking about. And this is just output. So so the HV, I'm sorry to flip like that, but just to show you my setup here and the sides of so there are two MOSFETs in the bottom for the HV push-pull configuration, and in the middle, as you see, it's a split phase. So it's a split phase, and I'm talking about this one here. The transformer is a split phase using a Y16 core, high frequency. And I'll go back to diagram. Then the first one is the HC. I mean the HV. The HV is this one here. So side of the transformer is grounded. The other side is connected to the HV. And so that's the transformer, the split in here. The split is taking from 0 to 30 volt with snubbers, and just to protect the MOSFET of the push-pull. And this is the HV. One side is we measuring the HV, which you're gonna see shortly, and the other side is connected to the transformer. and there is two symbol here for grounding. This ground is for the grounding of the power supply, that symbol. And the earth is another symbol here, which means it's connected to earth's ground. It's not the same grounding, okay? So it's kind of floating. Okay, so after the HV, we have the OC, which is the output coil, and it's with a load of 16 ohm. That's my setup to match the impedance of the HC, or the OC is the same impedance, which in my case calculation bring me 16 ohm. And you will see in here, you'll see this is my load over here. It says 1, 2, 3, 4, 5, 600 ohm in parallel, which bring you to 16 ohm. Then after that we had the HC. The HC, the high current, had a capacitor. My HC have a 280 nanofarad. This is the parallel capacitor which bring the HC into resonance, and this is the resonance start with 45 kilohertz, that the HV, and then it goes down to 33 kilohertz. So that's my setup, as you notice. Then I'm gonna go to testing. This video is just to show that there is power, that's all. I'm not showing a video for tuning. That took like 1 week to do, just for tuning. There is so many parameters that we play with, the capacitor and the HC, even the sides of the switching, it make a difference. And also the split of the transformer. This doesn't mean at all that I'm not gonna say my setup. I'm gonna make another proper, thorough video for tuning if that's needed. I'm not sure if it's needed. But anyway, so based on this, the circuit, you will see in the scope the four channels. The first channel is 1000X, which is these two, one for the HV and one for the HC voltage. This is the voltage. And then the third channel, you'll see it in blue, is the current, which in this case I'm putting the current probe on the load, but I will also show you the current on the HC. So we're gonna see now testing, which I already tuned the circuit, so don't wonder about tuning. So as I said, I'm using these two transformers for push-pull, and this one is for HC. If I want to use the other one, I will need to switch the MOSFET the other side, and I will show you now. So I'm gonna turn the circuit on. The MOSFET already switching on and off for the split, okay? And I'm putting actually 30 volt, and you will see here in the if it's too far, I'm going to tell you the values. Probably you can see it, but I'm going to tell you the values for the HV and the HC. As for this board, it's taking 12 volt. It's only 12 volt. And these are my controls. This is for the pulse width. These are for the delay. And this is for the frequency. Okay. As I said, the frequency for the resonance of the HV, my HV, is 45 kilohertz, I'm sorry. And this is for the pulse width. And this is for the delay, which I adjusted the impulse to be in the highest point of the HV volt. And you will see that the output of the OC, the current in phase with the voltage, with a higher power than what we putting in. So let's see this. Now I'm going to turn the power on. And I'm going to put the scope in screen. So what we have here is the, you see in pink is the impulse. And you will notice here the temperature is already rising. 25 now. It was 24, 25.4. And you will see that that's why I put this toward you. And in the scope, you will see the temperature. I'm sorry. I have to switch it to this screen. I just set up this OBS thing, and I'm not very familiar with it. I just set up this morning. So I'm back to the scope. So the scope is showing 1.64, and the HC is not on yet. I mean, there is only 3 volt. So I'm gonna turn the HC on now. You see the voltage of the HV is increasing to 2 kilovolt, and the amps is 3 amp peak to peak. Now I'm gonna show you the screen where is the temperature is already 31 degrees, and it's going on. The consumption on the power supply is 31 volt at 0.30 amps, and the HC is 24 at 0.28, 33. Now I'm gonna put the probe. I'm gonna turn all off. I'm gonna give you the scope. I'm gonna turn on off and show only the current. So this is the current 2.54. If I increase to the max of the HC, it gives 3 point something in peak to peak. And the RMS is about 0.7 amps. As for the voltage, is 400 peak to peak. It's not very sine wave, but the current are sine wave. And let me see here. You see it's in phase. Here we go. So you see it here clearly that the impulse is in the middle of the highest point of the voltage, and the voltage is in phase with the current. That's why you have a resistor of 16 ohm is rising in temperature at 46 now from 24 in a few minutes. So that's all what I want to show, and I think uh, I think this is a good result. That's the best result I ever seen on this system now. It could be, of course, could be better by tuning more, but I just wanted to give you the good news that it is working and it's giving more power than the input, and that's all. So thank you very much for watching, and until to the next video.